Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Amri bin Ramli. This is my proposal presentation for the final year project 1. The project title is Design, Build and Fly a Radio Control RC Flying Wing. My supervisor name is Dr. Zurati Muhammad Ali and my co-supervisor is Dr. Zulhimi Sahwi. For the project summary, this paper discusses about the research study that design, build and fly a radio control RC flying wing. Then, the purpose of the study is to provide an overview of the methodology and involved in the design of the flying wing. For the presentation outline, start with introduction, literature review, problem statement, objective, scope of work, methodology, expected result, planning, and lastly, references. Now, we go to the introduction of the study. A radio control aircraft is a flying vehicle that is remotely controlled by a ground operator using a handheld radio transmitter. Flying wing is also known as a telescopic wing aircraft with no defined fuselage. One of the advantages of the flying wing is the height lift to drag ratio. Flying wing also is aerodynamically efficient aircraft design according to the theory. Next, for the literature review, this is the summary of the literature review. Design and construction endless flying wing aircraft by Elmore and A. Pion in 2019. Even after more than a century of research, the development of the flying wing is still viewed as a unique and unconventional aircraft concept. Next, basic design of flying wing models by Martin Heppel 2018, which is tailless plane and flying wings can be equipped with almost any airfoil if sweep and twist distribution are chosen accordingly. Thus, the one and only flying wing airfoil does not exist. Next, airfoil selection procedure, maintenance experimentation and implementation of stick DOF modeling on a flying wing micro aero vehicle by T. Sham, C. SIA Shah, AJF and SHR Hamdani in 2020. Reflects efforts fulfill both the requirements of lift and pitching moment. And next, design and production of small tailless unmanned aerial vehicle SAKR2 by M. Zakaria, M. Abdallah, and M.A. Al-Shafi in 2012. The effort selection will affect the stability of the flying wing. To have a stable flying wing, we choose the effort with positive or zero pitching moment coefficient. Next, micro aircraft competition design flying wing by K. Creighton, R.F.B. Lopez, T. Momos, and N. Pomelo in 2013. The wings were required to operate reliably at both negative and positive angle of attack, making symmetrical airfoil a natural choice. And lastly, design, build, and fly RC flying wing by A. Hamada, S. Sultan, and M. Abdurrahman in 2018. But form has more advantages than the balsa wood in terms of cost and easily to handle. It is inexpensive and easy to purchase, costing far less than the balsa block of same size. It is consistently of excellent quality and widely accessible. For the problem statement, firstly, small number of journals about the flying wing, and then cost of materials to build the flying wing is high, and lastly, lack of hands-on experience on RC flying wing. For the objective of the study, to design a RC flying wing, and then to build a RC flying wing using proper materials, and lastly, to test and fly a RC flying wing. For the scope and limitation for the study, design, build, and fly a RC flying wing. The flying wing will be able to launch and climb, and then the flying wing will be cruised at low speed, loiter, descent, and landing. For the limitation for the study, the endurance will only for 10 minutes, the range of the controller only for the 500 meters, and lastly, there's no internal testing for the study. Methodology is critical since it will prepare the Where for the selecting the best approach for the project, the figures show that the flowchart of the design methodology. Firstly, start the mission specification, and then statistical analysis, and next preliminary design, aerodynamic analysis, detailed design, simulation, and lastly flight test. For the mission specification, the size of the flying wing will be selected such that it's neither too big or nor too small. This is done to make the production process easier and to eliminate the stability issues. The figures show that the mission requirements are for the propulsion system. The choice is the electric motor with propeller, and then the endurance is about 10 minutes. And lastly, for the range is the 500 meters. For the statistical analysis, to further identify the initial values for the flying wing, statistical analysis is used to collect and analyze data from various literatures. The fitted curve approach may be used to estimate the design's weight and speed. For the first graph, the graph of the weight versus span. The graph shows that the higher the weight of the flying wing, the wider the span of the flying wing will be. And next, for the second graph, the graph is of the span versus the speed. The graph shows that the smaller the span of the flying wing, the higher the speed of the flying wing will be. For the preliminary design, the process of determining the upper design idea of flying wing is in the preliminary design. The kind of FY is chosen throughout this phase. The choice of FY is very crucial in defining the flying wing's flight performance. And for this project, the clockwise FY was chosen as the FY because of it has a lot of camber and which provide for a good lift to drag ratio. In addition, clockwise FY is generally known for its high stability at low Reynolds number. Furthermore, the clockwise is desirable because to its near flat low surface which assists the building of wings. The figures show that the clockwise FY. For the detailed design, the electronic component of the flying wing is determined at this point. The electronic component used will help in the flying wing's propulsion and control system. The table shows the electronic component that have been chosen. For the electric brushless motor, it used 2,200 kilovolt, which is about 47 grams. And for the electronic speed controller, the constant current is 50 ampere and 43 grams. And for the battery capacity is 1,300 mAh, which is about 113 grams. And the pitch for the propeller is 4 inch, and the diameter of the propeller is 6 inch. And lastly, for the micro servo motor, the torque is about 1.8 kilogram centimeter, which is about the 13.4 gram. Combat was chosen as the material for this project because lightweight and lower cost. For the computer aided design, SolidWorks is chosen for software to draw the design of the flying wing. The figure show the design of flying wing using SolidWorks. For the simulation and flight test, simulation is used to replicate the performance of flying wing in the actual world. For the flight test will establish whether or not the flying wing was successfully designed and built. Next, we go to the expected result. For the expected result, it is expected that the outcome of this project is to produce RC flying wing that has performance and aerodynamic data. This is the overall Gantt chart for the final year project 1. All the given task has been done within the time. Next, this is the references for the study. This is my contact information, and that's all for my presentation. Thank you for your time and thank you for listening. Assalamualaikum warahmatullahi wabarakatuh.